Let's solve this equation by completing the square. To complete the square, I'd like to turn one side, the left-hand side, I suppose, into a perfect square trinomial. To do that, I'm going to first move the constant term to the other side. So I get x squared plus 6x. If I add 1 to both sides, I get a positive 1 on the right side. And then I want to think about what I have here, x squared plus 6x. There's a number I can add to the end that will turn that into a perfect square trinomial. That number turns out to be 6 divided by 2 squared. So 6 divided by 2 gives me 3. If I take 3 and square it, I get 9, and that's the number that I want to add to both sides. So I'm going to add 9 to both sides of that equation. So x squared plus 6x plus 9 equals 10. So 9 is the special number that I chose to complete the square, because if you think about it, let's try to factor this side. To factor this, I want to look for a pair of numbers that multiplies to equal 9 and adds to equal 6. 9 is the special number that I get with 3 times 3. 3 times 3 equals 9, and 3 plus 3, because we got 3 by dividing 6 in half, we're guaranteed that 3 plus 3 equals 6. So this factors as x plus 3 times x plus 3, or more simply, this is x plus 3 squared. So we've created a perfect square on the left-hand side. That allows me to take the square root of both sides. I can take the square root of x plus 3 squared, and I can take the square root of 10, and when we do this in the context of solving an equation, I need to include a plus-minus possibility, because both positive 10 or negative 10 could be the square root. When we apply the square root to two sides of an equation in order to eliminate a square. So x plus 3, it could equal positive or negative square root of 10. Subtracting 3 from both sides gives us the final solution. I get x equals negative 3 plus or minus the square root of 10. So the two possible solutions are negative 3 plus the square root of 10 and negative 3 minus the square root of 10. Now let's see how we can use the quadratic formula to check our work. The equation that's given, it's set up in standard form, in the form ax squared plus bx plus c equals 0. So we see that a equals 1, because there's no number in front of the x squared term, b equals 6, and c equals negative 1. The quadratic formula says that the solution to this equation is x equals negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a. So plugging in the values that we found, we get x equals negative 6 plus or minus the square root of 6 squared minus 4 times 1 times negative 1, everything divided by 2 times 1. And let's see how this compares to the solution that we found a moment ago. A moment ago we said the solution is x equals negative 3 plus or minus the square root of 10. So at first glance this might look a little bit different, but it's actually the same answer. I have negative 6 plus or minus the square root of 36, and then since we're multiplying by a negative, I get a plus 4 under the square root, everything divided by 2. And so we can see maybe, the negative 3, it's going to come from negative 6 divided by 2. But under the square root, I have a plus or minus the square root of 40. Remember, though, we can factor out perfect square factors. 40 is exactly 4 times 10, and the square root of 4 is 2. So this is the same as negative 6 plus or minus 2 square roots of 10. And that's actually a really good thing, because in order to divide the 2 in the bottom with the numerator, I need 2 to be a factor of both of those. So we can kind of think of the fact that there's a common factor of 2. Negative 6 is 2 times negative 3, and 2 times the square root of 10 is the same as 2 times the square root of 10. And so that common factor of 2 from the numerator cancels with 2 in the denominator, and we see that the answer is in fact the same as we saw by completing the square. I hope you enjoyed the video. Thanks for watching.